All right, so in class today we looked at and reviewed how to solve absolute value equations and inequalities. What you're going to do as kind of an addendum to this lesson is to look at the graphs of the absolute value function. So what we're going to do to get this started is for each of the following functions, we are going to just make a table of values and then graph it by plotting those points from the table. I would suggest that you complete each graph in a different color so that you can really see which function corresponds to which graph. So, you all understand, or you should understand, what the absolute value bars mean. So all we're doing here, and I'll do this, let's say in red, you choose whatever color you prefer. All we're doing here is plugging in our value of x, the first one is -2, into the absolute value. So think about the absolute value of -2, that is +2. Think of that f of x as the same thing as your y, it's just a different notation. So doing each of these x values, plug in -1, so the absolute value of -1 is 1, and so on. Absolute value of 0, absolute value of 1, absolute value of 2. So you might be noticing some things here with these y values. Let's go ahead and plot these. So remember, this corresponds to the ordered pair, -2, 2, and so on. So down below on your grid, you can go ahead and plot those 5 ordered pairs. And then take a straight edge, or just do the best you can to connect those, and keep in mind that those are going on forever. We just looked at 5 points, but those are going on forever. So notice the absolute value function, your y values are only positive, and that's because the absolute value of a positive or negative number is positive. And notice that it's also pretty symmetric. All right, so we are going to do a similar type of thing here for these next 2 functions. So notice the second one. Here what we're doing is we're taking our value of x, we're taking the absolute value of that, and then we're adding 2. So the absolute value of -2 is 2, plus 2 is 4. Again, you're taking that value of x, plugging it in, taking the absolute value of that, and then adding 2. Absolute value of -1 is 1, plus 2 is 3. Absolute value of 0 is 0, plus 2 is 2, and so on. Absolute value of 1 is 1, plus 2 is 3. Absolute value of 2 is 2, plus 2 is 4. Again, you might be noticing some things in those y values. We're going to do the same thing. We're going to take those points from our table. We are going to plot them on our grid, the same grid we already have used. I should be using my straight edge, but I'm not. So what I want you to notice and look at, and just from the first to the second function, when we added that +2 on the end, what happened to the graph? Okay, think about that for a moment. When we added that +2 onto the end of the function, from the red to the blue, what happened to the graph? Hopefully you're seeing that g of x equals the absolute value of x plus 2. All that did was moved up 2 units. And this is a specific example for a general thing. let's say we had a +3 there. It would have moved the original up 3. If we had a -5 there, it would have moved the original down 5, okay? So when you have that plus or minus on the outside of the absolute value, that's going to move your graph up or down. Now let's look at putting a plus or minus inside the absolute value. So choose a third color. So now what we're doing is a little different. We're taking that value of x, plugging it in, subtracting 1, and then taking the absolute value. So it's a little bit different than what we did on the last one. So taking -2 minus 1, that's -3. Absolute value of -3 is +3. -1 minus 1 is -2. Absolute value is 2. 0 minus 1 is -1. Absolute value is 1, and so on. 1 minus 1 is 0. 2 minus 1 is 1. Again, you might be noticing something in those y values. Let's go ahead and plot those. Use my straight edge here. And just keep in mind, we're not getting a full picture of this graph with just 5 points. So that's why we need to extend those out. So now what I want you to think about is what happened from the red graph to the purple graph. We took that x, we subtracted 1 on the inside, but then look what happened to the graph. This one's a little counterintuitive. When we add or subtract inside the absolute value bars, it moves it left or right, but it kind of moves in the opposite direction that you might think. Okay, we have x minus 1. So you might think that minus means you move to the left, but like I said, it's a little counterintuitive. That means we move 1 unit to the right. If that were x plus 1, that would move your graph to the left, okay? All right, what I would like you to do is a very similar thing. There are 3 more functions, 1 more graph. You are going to do a similar thing, kind of compare from the original and then to the 2 second and third graphs. See how the changes in the function affects the graph, and then make some observations. And then I'll kind of come back and I'll show you just a little bit of, in general, these shifts and stretches. So you need to stop the video at this point. You need to complete those 3 tables and the 3 graphs. And then you need to write down some observations that you're seeing. And then we'll come back and finish that chart. So stop your video now to do that. My hope is that you stopped your video to fill this out on your own. I have it here. If you're just going to copy my work, then you're not really doing the learning. So that will show here soon. So hopefully you're doing this work on your own. You should have filled in the tables. Make sure if you did do this on your own, just double check that you do have the correct values for y in each of those and that you have the correct graphs. So what you should have been seeing when we multiply on the outside of the absolute value by 2, from the blue to the red, what happens is it kind of stretches it vertically by a factor of 2. When we have that 1/2 out in front, that compressed it, made it wider. Okay, so those are some things that you wanted to mention over here. Okay, the very last thing then that we're going to do here in this video is just sum up. We've already said these things, but I want to sum up one more time these graph transformations in general. So let's say we have our function f of x, and we're adding a constant, meaning we're adding 2 or adding 3. What this does is this moves up c units. So whatever that number is, that's how many units it moves up. If we had f of x minus c, then your graph would move down that number of units. And that was the first thing that we saw. A horizontal shift, meaning left or right, this is where we're adding or subtracting inside the absolute value. This one would move to the left c units. This is the one that's kind of opposite what you would think. And then f of x minus c, this would move to the right c units. For the vertical stretch and compression, this is what you saw here in these two examples. If you're multiplying a number outside of your function and that number c is greater than 1, then you are going to stretch it, make it skinnier. If you multiply outside of your function and that value of c is less than 1, meaning essentially a fraction, then this is going to compress it, make it fatter. All right, so this information should help you on the last couple problems of your homework.